A huge thanks to Brilliant for sponsoring this video. Good morning, fellow mathematicians! Welcome back to another video. It has been 4 years by now that I have last worn a hat on my channel, so yeah, here goes, wearing a hat for today's video. So this right here is going to mark the last video of the year on the 31st of December today. During the Advent calendar, I walked through the GCSE high school exam. It's a British one, the people who can pronounce the word were correctly. And yeah, it was a lot of fun. I did a few mistakes. And I did a lot of things right. You can find the link down there in the description. But many people said, don't do the GCSE. That's rather boring. Why not do the A-level maths exams? And this is exactly what we are going to do today. Before we get to the further maths section, at first I would just like to take a look at the A-level Edexcel exam in pure mathematics today. Once again, it's going to be a blindfolded run, you could say. I don't know what the contents of the exam are going to be, but I think I have kind of an image before my eyes, because I now know what they look like, at least for the GCSE, and I'm pretty excited about the Edexcel one, which you can find over here in a second. Other than that, video has been sponsored by the wonderful people over on Brilliant. More information during the video. Also, 2 more little PSAs. You might have seen it before, the Cyber Tensegrity recently dropped on StemMerge EU. It looks beautiful. Check it out. Link to StemMerge EU and the Cyber Tensegrity down there in the description. Also, I did a very epic collab with my guy Jonathan Katz-Moses over on his channel, where I tried to explain the physics approximately around table saw kickback. It was a lot of fun. 50,000 FPS slow motion camera footage. That's a lot. Turned out to be a very nice video. Go ahead and check it out. It was such a lot of effort for both of us, and you should definitely make sure to check it out. Link down there in the description. And now we're going to dive right in. So at first, let us take a look at what Edexcel actually is and what it contains. So there are many different sections like statistics, mechanics, etc. in this exam. And I didn't know about all those exams in the British territory before, but then one person over on my subreddit created a very nice comprehensive guide on all of these. And I decided to go with the Edexcel one because why the hell not? I think it was just the first paper that has been linked here from 2019. We are going to go with the 2019 version once again, just because anime canon. Okay, we are going to go with the 2019 ones because why the hell not? And you can click on all of these links, link down there in the description to all the Reddit things, and then you can get your hands on all the past papers. And as mentioned before, I decided on the Edexcel one. And it's the Pearson one, and we have 2 hours to solve this bad boy. I hope it's not going to take me 2 hours. I was half an hour earlier on the other one too, so maybe we can do it in the same amount of time. And it's going to be the advanced one in pure mathematics, number 1, the first paper. And what you must have is mathematical formulae and statistical tables and a calculator. I'm not going to use any of these. I'm just going to try my hands on everything without any kind of preparation and formulas, etc. I don't know what you can take in exactly, if it's just lookup table or the like, but I'm just going to let myself be surprised. And if I can solve something, then it is what it is. I mean, it really doesn't matter. It's just for the sake of fun. And other than that, instead of a piece of paper, I'm going to use my Gaumon PD1560 tablet, because many people were asking what I'm writing on. Link down there in the description too to one of these. It's not sponsored, nothing of that sort, but it's a very nice tablet. You should get your hands on one of these. And yeah, let's go ahead and get started. Timer is going to run in a second, and we're going to see how I'm going to perform. Fingers crossed. Ooh. That's going to be a lot of work, I suppose. Harder than the last one, probably. Okay, answer all questions. Write your answers in the spaces provided. 3x cubed plus 2ax squared minus 4x plus 5a. Given that x plus 3 is a factor of f of x, find the value of the constant a. Okay, so let me see it. So f of x is equal to, that's shaking for some odd reason, 3x cubed plus 2ax squared minus 4x plus 5a. Okay, we need to find the value of the constant a. So what you probably need to do is polynomial division. I don't, for the sake of it, know how to do polynomial division. This is why I'm going to go with my regular method. Namely, we are going to decompose f of x into x plus 3 times something new. So, okay, so times some quadratic polynomial. This is what we need. Quadratic polynomial, we need a 3 as the factor in front, 3x squared plus. I'm not going to go with a, let's go with bx plus c. This is going to turn out to be 3x cubed plus, and next up we are going to get plus bx squared plus cx. Then we are going to get plus nan x squared plus 3bx plus 3c. So if we were to bring everything together, x cubed, for some reason my tip, just a tip, is a bit large. Yeah, my tip has always been rather large. All the ladies know it. So plus b, and then so we got this one, and 9 plus 9 x squared. Then we got plus 3b plus cx plus 3c, meaning 3c is equal to, so we got a system of equations, 3c is equal to 5a. What we also got is 3b plus c is equal to -4, because that's the coefficient of our x. And we got 2a is equal to b plus nan. Okay, this is what we got at this very moment, meaning if we just solve the system of equations now, we know that up here a is equal to 3 over 5c. What we also know is if we plug the c into here, we know that, oh yeah, no, we can go the other way around. That's equivalent to saying c is equal to 5 over 3a. Meaning if we plug this into here, we got 3b plus 5 over 3a is equal to -4. And now we can start solving these two equations. Okay, okay, let's see. So we got, if we divide all of this by 3, I mean, all that we need to know is a. We only need to know the value for a, so that is good. If we were to divide everything by 3 here, we are going to get that b plus 4 over 3 is equal to -5 over 9a. Okay, because 3 is not equal to 0, hence we can divide by it. Other than that, if we were to now subtract these two guys that we got here, we are going to get that b is going to cancel out. We got 9 minus 4 divided by 3 is equal to 2a plus 5 divided by 9a. Meaning that's equivalent to saying we got 27 minus 4 divided by 3. Yeah, is equal to, adding these two together, something times a. So we got 18 plus 5 divided by 9 is equivalent to saying we got 23 divided by 3 is equal to a times 23 divided by 9. Meaning we can cancel out 3's here, so 1/3. We can cancel out the 20/3. That means that a is equal to 3. A is equal to 3, and I hope this is correct. Do we have to do anything else? Find the value of the constant a. Yeah, that's everything. A is equal to 3. Okay, continue. Yeah, that was a very effective method. Let me zoom out a tiny little bit. Figure 1 shows a plot of part of the curve with equation y is equal to cosine x, where x is measured in radians. Diagram 1 on the opposite page is a copy of figure 1. Use diagram 1 to show why the equation cosine x minus 2x minus 1/2 has only one real root, giving a reason for your answer. So we need to use the diagram that is given in our plot. I suppose that is rather easy. So if we take a look at the cosine is just going to be this guy here, where since it's cosine x, it passes through 1, and down here we got -1. So if we have this equation, cosine x is equal to 2x minus 1/2, no, plus 1/2. If we solve this equation with the original one being cosine x minus 2x minus 1/2 is equal to 0, then basically what we're going to do is we are going to set cosine of x equal with this polynomial. Or if we want to find the zero of the subtraction of these two functions, it's just going to be the intersection of these two, meaning 2x plus 1/2. So 1/2 is here. This is going to be its y-intercept. It's going to pass through here. And 2x is, okay, rise over run. So let me see for a second. Power over 2, 0, power over 2. Power over 2 is 1.5, something of that sort. 1.5, okay. So just approximately. So we got 2x. This is delta y divided by delta x. So this is 2 divided by 1. So we go 2 in this direction. No, 2 divided by 1. So we go 1. This is up here. So something here. Okay. And then we are going to go one step to the side. Okay, meaning it's going to be like this. And if we now draw our graph, looking something of that sort, I could have also just calculated the zero of 2x plus 1/2, but this doesn't matter. We can see graphically that it's definitely just going to intersect in one point. Yeah, and this is basically it. Has only one real root, giving a reason for your answer, because we only got one intersection point. Given that the root of the equation is alpha and that alpha is small, do we need to use this fact? I don't think so. I mean, if alpha is small, where they want to go at is probably use the small angle approximation. Meaning for the small angle approximation, is this alpha or a? Really doesn't matter. So we got 1 minus 1/2 minus 2x. That's a minus, is equal to 0, because cosine of x small angle approximate is just 1, obviously. Then we got 1/2 minus 2x is equal to 0. And I don't think that this is very... Oh no, this is for part 2. I'm being stupid. Given that the root of the equation is alpha and that alpha is small. These questions are fucking me up from time to time. Same thing with the shaded area circle in the last one. That was just fucking stupid. That wasn't well formulated in my opinion. Use the small angle approximation for cosine of x to estimate the value of alpha to 3 decimal places. Yeah. So that the root of the equation is alpha. Yeah, if it's a root of the equation, if we plug alpha into there, it's just going... Yeah, I mean, this right here is the small angle approximation for the whole thing. That's equivalent to saying we got 2 alpha is equal to 1/2. That means alpha is equal to 1/4, meaning 0.25. I hope that is correct. I don't know to which degree they go on the small angle approximation. I can tell you, because the small angle approximation, if you want to do it basically a bit more sophisticated, you can also say that it's 1 minus x squared over 2 for the cosine. Then it becomes a bit more sophisticated, and then we have more alpha in here. But other than that, I think that is totally fine. 0.25. I don't think that, yeah, that this is a problem. Yeah, okay. I'm going to go with this answer, obviously, because I don't know better at this point. Because I don't know what they want to see exactly. This is like the biggest problem between me, the German maths teacher, and this exam. So next up, let me write it out for a second. I zoomed out accidentally. Okay, that's a bit better. Show that, okay, so we got y is equal, before we start to show something, let's just write it out. 5x squared, and then we got plus 10x divided by x plus 1 squared. X is not, yeah, obviously x not equal to 1. Show that dy dx is equal to blah blah, where a and n are constants to be found. I mean, if we just differentiate, so dy dx is equal to the differential operator applied to the multiplication of 5x squared plus 10x times x plus 1 to the negative 2 power, meaning if we were to make use of the product rule now and the chain rule, we are going to get, so differentiating this is going to give us 10x plus 10 divided by, yeah, divided by, what they probably want you to use is the quotient rule, because with this you're going to get the answer out immediately. I don't have it in my head because it's just fucking stupid. It's just a consequence of the product rule, but never mind. 10x plus 10 divided by x plus 1 to the negative 2th power. And then minus, and then we got 2 times what we have on the top, so 10x squared. Plus 20x divided by x plus 1 to the negative 3rd power, meaning if to the negative 3rd power obviously, and squared over here, not to the negative something, just to the just to the something. If we were to expand this by x plus 1 over here, so overall we are going to get x plus 1 squared. Then over here we are going to get 10x squared. 10x squared plus 10x plus 10x, so this makes 20x plus 10, and then we got minus 10x squared minus 20x. Obviously what we are going to notice is that this and that is going to cancel out, this and that too, giving us overall, and to the 3rd power obviously, 10 divided by x plus 1 to the 3rd power. And this is what we had to show. Hence deduce the range of values for x for which dy dx is less than 0. So we need to find out for which it is less than 0. That's the equation we need to solve. Supposing x is not equal to negative 1, which we do suppose because of the restrictions in the domain on our exercise, we have that oh yeah, give me a second. So 10 is a constant, so that's equivalent to saying we need to check when 1 over x plus 1 to the 3rd power is less than 0. This is obviously the case since it's a third, it's a 3rd degree polynomial. It's also an odd function which we are going to deal with. No, it's not an odd function per se, but the 3rd power is going to indicate that we can track the negative sign to the front. Meaning this holds if x minus 1 is less than 0, or equivalent to saying we got x is less than 1. Okay, obviously, if it's, for example, if x is equal to, no, give me a second. This is plus 1. X is less than minus 1. Yes, now it does make sense. If it's, for example, negative 2, okay, then we got negative 1 to the 3rd power. And this is just negative 1, so 10 over negative 1 is negative 10, for which it is less than 0, meaning x must be less than negative 1. And this is, I think, what we needed to show. Okay, next up. Up until now, it's totally okay, I suppose. It's not too hard. That's right up my alley, I think. Find the first 3 terms in ascending powers of x of the binomial expansion of 1 over square root of 4x, giving each coefficient in its simplest form. Okay, let me think for a second. So if we got x minus, no, plus 1, let's go with plus, to the nth power, that's the same as, oh no, now I need to think. Now a formula sheet would have been fucking amazing. K being greater or equal to 0 up until n. I think it's n choose k divided by x to the n times y to the n minus k. I hope this is correct. I always have trouble because I tend to mix up the n and the k's with the binomial expansion, and I haven't used it in like ages. Last time I used it was on my master's thesis, so this is like 2 years ago, but I think this one should be right. Meaning what we are going to do is, if we let n for element of the real numbers, then obviously it's going to become a series expansion. Do they even cover this already for series expansion? I'm going to go with this. I don't know better, honestly. Meaning we got 4 minus x to the negative 1/2 is equal to the infinite series, where k is greater or equal to 0 up until infinity, of holy fucking shit. I mean, in normal case you would need to use Taylor series for that. This is rather curious. Negative 1/2, okay, x to the negative 1/2, y to the negative 1/2 minus k. I don't think that this is the way to go, seriously. I don't think that high school students or something of that sort are using like Taylor series expansions. I don't believe that. Find the first three terms in ascending powers of x of the binomial expansion of blah blah blah. Possible values of x that could be substituted into this expansion are, I mean, I'm not very certain what I should do. This just screams for the Taylor series expansion. I'm going to go with the Taylor series because this is just a binomial expansion in a nutshell, you could say, what I did up here. I just don't know better. I'm terribly sorry for that. It just is what it is, I suppose. Let me see for a second. So f of x is equal to 4 minus x to the negative 1/2. That means f prime is equal to negative 1/2, 4 minus x to the negative 3 over 2, then f double prime. And those are going to be the first three terms, obviously. So negative 1/2. So this is going to turn into positive sign 3 over 2, 4 minus x to the negative 5 over 2. Meaning overall, our Taylor series expansion 1 over square root of 4 minus x is approximately. So we also need our, so in a normal case, this is the sum from k to infinity of f, the decay derivative in f of 0. We are going to go with the Maclaurin series expansion k factorial times x to the kth power. Yeah, meaning that's approximately, in our case, so this right here is equal, and other than that, it's approximately f of 0 here is just going to give us 1 over the square root of 4. And then we are going to get minus 1/2 times 1 over the root of 4 cubed plus, and then we're going to get 2 factorial, meaning we're going to get another 2, 3 divided by 8, and then we are going to get, oh yeah, and also we need to plug in an x, obviously. I'm terribly sorry about that. Not on the very 0th term, not on the very 0th term, but we need an x squared here. And then we got the square root of 4 to the 5th power plus o x to the 3rd power. Yeah, that one's eating away a lot of time, and I'm probably doing it completely wrong. This is probably not what they want from you, but never mind. So this is 1/2, so we need to approximate it at square root of 2, so x being equal to 2. This is what we are going to do. Minus 1/2, and this right here is going to be 2 to the 6th power, so the square root of that is going to give us 2 to the 3rd power, obviously, so this is 2 to the 4th power, or in other words 2, 4, 8, 16, 1/16, and then times 2, meaning this is going to give us 1/8 overall. And then let's see how well we are going to do overall. Then plus 3 times, that's going to give us 4 divided by 8. This is going to give us 2 to the 5th power. 2 to the 5th power, 8. 2 to the 3rd power, 2 to the 8th power is going to give us 256. That is fucking stupid. 256, but this divided by 4 is going to give you 64. Yeah, nice. That is very, very nice. Okay, this is our approximation at this very moment. Meaning this is 0.5 minus 0.125. So this right here is 0.375. No, wait. We need to approximate square root of 2. So this right here is going to be 1 over square root of 2 overall. This right here, oh shit, I'm being stupid. So this is 1 over square root of 2 approximately. Meaning 64. We need to expand this by, let me see, 46. Then 8, so we got 3 minus 8 times 8. Yeah, minus 8 plus 3. And this 2 times 32 is equal to negative 5. So 27 over 64. Meaning square root of 2 is approximately 64 over 27. What do we need to do? That's an approximation. Yeah, that's definitely an approximation. I mean, why should I turn it into decimal? They don't want decimal at this very moment. This right here is my gut-forsaken approximation, and I'm totally fine with that, and it's something like 2 dot. I couldn't care less at this point, to be honest. They only wanted the first 3 terms, I suppose. Yeah, only find the first 3 terms. I'm fine with that. Without evaluating your expansion. State giving a reason which of the 3 values of x should not be used. I am very certain that x being equal to negative 14 should not be used. Just because for the Taylor series expansion or binomial expansion, it's not in the radius of convergence. Only, I think between 4, between 4 and 0, or a bit less than 0, really depends on the Leibniz conversions. But x being equal to negative 14, I don't think that it's in the radius of convergence. I don't believe so. And the value doesn't make sense, I can tell you. But I believe it just doesn't make any sense. Yeah. This is my reason. State giving a reason which of the 3 values of x would lead to the most accurate approximation for square root of 2. I mean, for a Taylor series expansion, the closer you are basically to the middle point of the radius of convergence, okay, the smaller the values get, you could say, the better the approximation obviously gets. If we take a look at this from a graphical point of view for the exponential function, if we have a Taylor series expansion and it goes like this, for example, this is our Taylor series expansion, for example, okay, at this point, obviously, if I choose a big value, okay, then this right here is not going to be very accurate for the first 3 terms on a 3rd-degree polynomial. But the closer our, or the smaller our values are that we plug in there, the better the approximation is going to be. Meaning what I would write is probably x being equal to negative 1/2 is going to be the most accurate approximation for our square root of 2 overall. I mean, we can multiply by 3, then we get square root of 2, and I think that should be good. So I would go with x being equal to negative 1/2. And I hope that's correct. Okay, next up. So write f of x in the form blah blah blah. Okay, so I can't remember the name of the form. This is like the parabolic form, okay? The normal form, as you would say in German, I think it is. B squared plus c. This is what we need to do for f of x being equal to 2x squared plus 4x plus 9. Okay, I mean this is fairly easy because this is the same as 2 times x squared plus 2x. So we need to complete the square. What is still missing here is, so we got a 2 here, meaning we need to get, yeah, plus 1 and minus 1. Meaning what we have is 2 times x plus 1 squared. Then we get minus 2 plus 9 is equal to 2x plus 1 squared plus 7. I think this should do the trick. Let me check. 2x squared, then we are going to get plus 4x, then we are going to get plus 2. And yeah, okay, this right here is my answer for the first one. That was easy. Sketch the curve with the equation y is equal to f of x, showing any points of intersection with the coordinates x's and coordinates of any turning point. Okay, if I were to sketch this, let me see. So this one is shifted 7 units in the upwards y direction. This right here are 7 units. So this is definitely what it's going to look like. What we also have is a parabola, which is going to be opened in the upwards y direction, meaning overall we are going to have no zeros. Which becomes clear if we take a look at 2 times x plus 1 squared being equal to negative 7, meaning overall x plus 1 is equal to plus or minus the square root of negative 7 over 2, which is not element of the real numbers. Since it has a factor of 2, it's a stretch parabola, so it's a pretty thin boy. So that one is the case. We got x plus 1. Plus 1 means negative 1 in the x direction shifted. So it goes through something like this. And what are the turning points? For this we are going to make use of the derivative. F prime of x is going to give us 4x plus 1, which is the same as 4x plus 4. And this must be equal to 0. And meaning, oh yeah, I could have read it off obviously immediately what it's going to be. But never mind, we get x is equal to negative 1. This right here is the extremal point. And obviously it's going to be a local minimum because it's open to the upwards y direction and it's being located at 7 and negative 1. Yeah, exactly. Yeah. Yeah. And our parabola is going to look something like this. Okay, it's going to be a small boy in comparison to our regular parent function. Okay. Describe fully the transformation that maps the curve with equation onto the curve with equation where the transformation. Let me write this out for a second. So I think what they mean is, for example, let x go to x minus 2, for example. That's what they probably mean by the transformation. So g of x is equal to 2x minus 2 squared plus 4x minus 3, meaning that's the same as 2x squared minus, so 2 times 2 times 2 is going to give us 8, minus 8x, and then plus 8 plus 4x, so meaning we got negative 4x minus 3, which is going to be the same as 2x squared minus 4x plus 5. So let me see for a second. Our original function was f of x is equal to 2x plus 1 squared plus 7, or in other words 2x squared plus 4x plus 9. Okay, I think the best thing we can possibly do is complete a square on this one once again. So this is 2 times x squared minus 2x. So we need to subtract the 1 and add it. Plus 5, meaning this is 2 times x squared minus 1 squared. Then we get 2 times 1, so plus 7. Why do I have an x squared here? And this makes way more sense now, because what we need to do is we need to let 2 times x plus 1 squared plus 7 go to 2 times x minus 1 squared plus 7. And all of this can be done by letting x go to x minus 2. Yes. The transformation is being described by plugging x minus 2 into our f of x, meaning f of x minus 2 is equal to g of x. If I'm not mistaken, and I hope this is what they mean. Find the range of the function. Okay. H of x is going to be equal to 21 divided by 2x squared plus 4x plus 9. The range of the function. All the things we are going to map to. Okay. So what we probably need to do, this is something I haven't ever done in my life. Not too much, but I think what we need to do is we need to find out the restriction of the domain, if there are any restrictions, and there definitely are. Okay, we definitely have some singularities here. And then we are just going to see if we plug the singularities into here or something of that sort, what wouldn't we get out? Let's just try it out. So 21 divided by, when is this equal to 0? So we got x squared plus 2x plus 9 over 2 is equal to 0, meaning x, 1 and 2 are equal to minus 1 plus or minus the square root of 1 plus, no, minus 9 over 2. Oh yeah, so meaning we don't even have any real zeros. Yeah, we don't have any real zeros, meaning the domain is definitely element of the real number. Oh yeah, they actually state this here. It's element of the real numbers. So let me see for a second. If I were to draw the sky, then we are going to get that this is 2x squared plus 2. Is this our function f of, yeah, this is our function f of x. I'm being fucking stupid here. I'm terribly sorry. Okay, I'm being retarded. But this doesn't matter. 2 times x, and then we got plus 1 squared plus 7. Meaning this right here is our function once again, which is situated here, looking like this. So we can't have any values for y. So y is always greater or equal to 7. So we don't have any values of y which satisfy this one right here. So our range, this one is always greater or equal to 21 over 7, which is equal to 3. Right? I mean, this right here are the range. Range is for x being greater or no, y being range is all the things we map to. Range is greater or equal to 3. So y being greater or equal to 3. Meaning, or in other words, y element of the real numbers. Okay, like this, starting from 3. Whew. This actually screams for a break right now. And do you know what the best way is to take a little break? It's by taking a look over to the contents of today's sponsor Brilliant, who are kind enough to sponsor yet another video here on this channel. Now for some of the things that I'm doing here at this very moment, like the range of a function, calculating it, I would have loved to get a little refresher over on Brilliant before getting started with this video. But it's all improvised here, so I couldn't do anything about this. But could be something completely different for you, because maybe you are preparing right now for some of these exams and maybe you still need to get a refresher on a bunch of things that you don't remember at this very moment. If this is the case, then Brilliant might be the perfect fit for you. Now what I'm doing here is just use a piece of paper, you could say, or a graphical tablet to evaluate things roughly. This isn't the way to go for many things, including school mathematics, school physics, etc. What you would rather like to do is take a look at a few interactive things that you can use to evaluate student results, like the range of a function. And Brilliant is able to provide you with exactly these interactive courses over on their website. Be it in mathematics, physics, chemistry, computer sciences. No matter what it is in the STEM field, Brilliant definitely has you covered with nearly 70 interactive courses in all of these topics I just told you about. This exam right here is actually extremely calculus based, as I just now noticed, and calculus is one of these parts of mathematics that you can learn extremely intuitively by taking a look at the graphs, varying parameters, and just playing around with the functions to get a feel for them. And just take a look at the interactive content of Brilliant. Isn't it beautiful? Taking a parabola, shifting around levers and just pressing a few buttons and trying to get an intuitive feel for all of these functions. It's not even too mathematics based, you could say. It's just learning by doing, and this is the base concept of Brilliant, and it's working perfectly. It has worked for me on a lot of different topics and it's definitely going to work for you. And if this feels like it's something for you, if you want to try it out for yourself, then why not make sure to check out the link at the top of the description, brilliant.org/randommaths. With it you're going to get 20% of an annual Brilliant subscription if you actually make use of the link, or if you just want to try it out for now, you can get access to a big portion of Brilliant already for free by making use of the link. So definitely make sure to check it out and to support the channel this way. And now we are going to go back to the main video. Okay, and that's hopefully it. And next, question 5, no, question 6. How many papers are there? You don't even need that much. What the hell? Okay, and this seems to be a trick question. Very, very tricky. Okay, so for theta between negative power by 2 and power by 2, the equation of giving your answers where necessary to one decimal place. No, 5 sin of 2. I'm going to use var theta because this is just a superior theta and the other one is just suck stick. 9 tangent of var theta. Once again, I'm not sure what is allowed here. I'm just going to make use of the things that I know, and what I see is a double angle formula, hence I'm going to use it. So we got double angle formula for the sine, so we got 10 sine of theta times the cosine of theta is equal to, so we got 9 times sine of theta divided by the cosine of theta. Sine is going to cancel out, but only under the condition that's not equal to 0. So yeah, that is actually one solution. So theta being equal to 0 is one solution, that is theta 1. Okay, and meaning we got cosine squared, so we got cosine squared of theta is equal to 9 divided by 10, or if we take the square root, we are going to get the cosine of theta is equal to plus or minus 3 divided by the square root of 10. I think you can use calculator, right? So this is probably doable then, but this is a more exact answer anyway, so I don't give a shit. And then if we use the inverse cosine, and on this interval it definitely works. It's definitely bijective on both sides, okay, depending on the branch of the inverse cosine, but we don't need to go into this. Theta 2 and 3 are going to be equal to the inverse cosine of plus or minus 3 divided by the square root of 10. Which is certainly something that I don't care about because I do not own a calculator. Fun story, I don't have a calculator, I only have Wolfram Alpha. That's the only thing I have, and that's the only thing you should use. Okay, next up, deduce the smallest positive solution to the equation. Once again, decrease. Okay. 5 times, no, what am I, no. 5 times sine of 2x minus 50 degrees is equal to 9 tangent of x minus 25 degrees. I mean, this right here is 2 times x minus 50 degrees, right? Meaning what we got once again is, so we got the double angle formula yet again. So 10 times sine of x minus 50 degrees times the cosine of x minus 50 degrees is equal to 9 times sine of x minus 50 degrees divided by the cosine of x minus 50 degrees. Okay, and deduce the smallest positive solution to the equation. One solution is obviously x being equal to 50 degrees. This works because then the argument goes to 0 and hence our equation is satisfied. If we cancel this out once again, we are going to get that once again, okay, this time we are going to get x, 2 and 3 is equal to the inverse cosine of plus or minus the square root, so we got 3 divided by the square root of 10 plus 50 degrees. And I can tell you if this is like the smallest possible solution or not, or one of these three. So one of these it's probably going to be. And I'm just going to guess, okay? I'm wildly going to guess that the negative branch right here is going to be exactly this smallest possible solution. I don't know, I'm just going to make a wild, very sophisticated guess here. This is why you can probably use a calculator. Okay, so many empty pages. Oh, no. I can see real life things and I don't like real life things. Please no probability. In a simple model, the value pound of V of a car depends on its age, T in years. The following information is available for car A. Its value when new is, so value, the value at T being equal to 0 is equal to 20k, 20,000. And the value after 1 year, so the value of T being equal to 1, is equal to 16,000. Use an exponential model to form for car A a possible equation linking V with T. I mean, if it's an exponential model, you can just form something, okay? So they don't talk about something very specific, an exponential model. So my wild guess is, so we definitely need something. V of t is equal to the starting value. This is definitely something that we need. After 1 year is over, it's only worth, so 16 divided by 20 is 4 divided by 5. So I would go with 4 divided by 5 to the tth power. That's an exponential model, obviously. And after 1 year, you're going to get just 20. So we got 20 times 4 is 80. Yeah, this works. After 1 year, so V of t being equal to 1, it's going to be 20k times 4 divided by 5 is 16,000. And this obviously works out. This right here is my exponential model. This is what I would guess is totally fine. We just need to come up with one. The value of car A is monitored over a 10-year period. Its value after 10 years is 2,000 pounds. Evaluate the reliability of your model in light of this information. Okay, meaning t being equal to 10, v of t being equal to 10 is equal to 20k times 4 divided by 5 to the 10th power. Holy shit balls. This right here is 2 times 10 to the 5th power, right? This is 10 to the 5th, no, to the 4th power. I'm being stupid. Okay, to the 4th power. Give me a second. 10, yeah. 4 to the, okay, then we got 2 to the 20th power divided by 5 to the 10th power. So this right here is 2 to the 21st power times 2 to the 4th power times 2 to the 5th power. No, wait, it's an exponential. Oh, no, I need to switch my answer. No, wait, no. I was thinking to the negative teeth power, but this is not the case, obviously. That's totally not the case. I totally forgot that we got, so we got times 5 to the 4th power, and here we got 5 to the 10th power. Meaning this is just 2 to the 13th power divided by 5 to the 6th power. Let me grab my calculator real quick. I can evaluate this in my head, obviously. It says 68,719. Okay. But this doesn't make any sense. Why should it? I mean, for t going to infinity, it obviously goes to 0. Meaning it can't, no, it's definitely not increasing. It's definitely decreasing at all times. What have I done wrong here? 2 to the 20th power, 5 to the... Wait, what have I done here? 2 to the 2 to the 21. This stems from this one and this one. And then we got, no, where's the 2 to the, no, this 2 to the 5th power doesn't make any sense. 25th. So that's a totally different order of magnitude, and I'm going to check this out once again. 2 to the 25th. Yes, that is better. I was doing something weird here. 2,147 pounds, approximately. Yeah, that is better. Okay, yeah, that's a good model. That's a very reliable model, and I can go with this, and I think this is what they were asking for. The following information is available for car B. It has the same value when new as car A. So the value for t being equal to 0 is equal to 20,000 pounds. Its value depreciates more slowly than that of car A. Explain how you would adapt the equation found in A so that it could be used to model the value of car B. I mean, if I were to say it, then the rate of depreciation is basically being given by some, let's say, n to the tth power, where our n is between 0, so strictly between 0, other than that it wouldn't make any sense, and 1. So meaning the closer it goes to 0, so n must be less than 4/5, such that we are going to get a better rate out. It deprecates slower. It deprecates more slowly. Meaning, no, this one must be bigger. No, n must actually bigger. So our n must be between 4 divided by 5, but strictly, and 1. Okay? So if it's at 1, then it's going to stay without deprecating at all times. This is not something that we want, but it must be bigger than 4/5. Just because if it's smaller than 4/5, then it's going to deprecate quicker, obviously. Because small numbers to a certain power are going to get smaller and smaller quicker. Okay, next up. Many empty pages. Once again, many empty pages. Holy shit. Okay, figure 2 shows a sketch of part of the curve with equation blah blah blah. Okay, let me go up here. Y is equal to x times x plus 2 times x minus 4. The region R1, so I'm going to draw it real quick. So we got this piece of shit here, and then we got this region, this is R2, and we got this region R1. The region R1 shaded in figure 2 is bounded by the curve in the negative x-axis. Show that the exact area of R1 is 20/3. Yeah, okay, easy. This one right here goes right through the origin. This is what we can see from our x, meaning one of the zeros is going to be, so the first 0 is going to be at 0, the second 0 is going to be at -2, and the third 0 is going to be at 4. This is just the factorized form, linear combination of the linear factors, and that is nice. Meaning the lower bound of integration is -2, meaning to get ourselves the area, we are going to integrate from -2 to 0 our, let me see for a second, this right here is x squared plus 2x times x minus 4, meaning this is going to give us x to the third power, plus, now we get so negative 4x squared. Then we are going to get plus 2x squared, so minus 2x squared, and then minus 8x. Yes, exactly. So this is what we need to integrate. Minus 2x squared minus 8x dx. Okay. Let's go ahead and get started. This is going to give us x to the 4th power over 4 minus 2x to the 3rd power over 3 minus 8 divided by 2 is going to give us 4, so minus 4x squared from -2 to 0. At 0 everything is going to vanish luckily, meaning we are going to get -2 to the 4th power. This is going to be 2 to the 4th power divided by 2 squared, meaning this right here is just going to give us 4, this is 2 squared, minus 2 times, and then we are going to get -2, so this turns into positive, 2 to the 4th power divided by 3, and then minus 2 squared, so -2 squared is just 2 squared, minus 16. Meaning we got -12, so we got -12 plus 16 over 3, which is the same as 16 minus, so we got, oh yeah, and we need a this is the second part of integration. I was already wondering, because obviously our area must be positive, but what I'm evaluating here is negative. But second part of integration, meaning everything is negative. Everything is negative if you're brave enough. Okay, so we got -16 plus 36, which is 20 over 3. And this is right. Okay, very, very nice. The region R2 also shown faded. Figure 2 is bounded by the curve, the positive x-axis, and the line. The region R2 also shown shaded in, okay, R2, this is the small portion that I have marked up here. Is bounded by the curve, the positive x-axis, and the line with the equation x is equal to b. Oh yeah, got it. Where b is a positive constant and b is between 0 and 4. Okay. Given that the area of R1 is equal to the area of R2, verify that b satisfies the equation. X is equals. What? X is equal to b. So this right here is a horizontal. No, it's a vertical line. And b is bounded between 0 and 4. Given that the area of R1 is equal to the area of R2. Okay. How can you verify this? I mean, the equation. Yeah, the equation for a line. Good question. I don't know this part. I'm going to get back to it maybe. Okay. I can tell you right now. Okay. Given that a and b are greater than 0 and a is greater than b, and they show that something is something. Okay, so logarithmic one. Log a minus log b is equal to log a minus b. This is something that I have covered in mathematics done right before, I suppose. So we got log of a divided by b by logarithm properties is equal to logarithm of a minus b. And since the logarithm is strictly increasing, we can also just compare our arguments, obviously. A divided by b is equal to a minus b, meaning overall that a is equal to ab minus b squared. What do we need to do? Oh yeah, meaning overall that b minus 1, that b squared is equal to a times b minus 1, or in other words, a is equal to b squared divided by b minus 1, where b is not equal to 1. Write down the full restriction of the value on the value of b, explaining the reason for this restriction. I mean, b is not equal to 0, obviously. This is not something that we can have. Main reason for that is obviously that, I mean, on the one hand, we are going to get a problem here, okay? Because then a would not be determinable. You can find a, obviously, it's going to diverge. No, wait, b is not equal to 1. No, wait. B can't be equal to 1. Because then we would have a is 1 divided by 0, goes to infinity. This doesn't work out. And also, we can't have it to be equal to 0. Reason for that is because our logarithm would diverge. Log of 0 would go to negative infinity. This is like the main restriction that we need to put on b. Not equal to 1 and not equal to 0. And that's probably it, I suppose. Okay, next up. Oh, a proof. Very, very nice. Okay. Prove that for all n squared plus 2 is not divisible by 4. Okay, n is element of the natural numbers, and we need to show that n squared plus 2, so that 4 does not divide n squared plus 2. Since they are natural numbers, we only have two cases, I suppose. I mean, you can probably do it by contradiction, or you can, yeah, or by induction. But we don't need this. So n even. We have only two cases, even and odd. Then n is equal to 2k, or in other words, if we plug this in, we got 4k squared plus 2 is the same as 2 times 2k squared plus 1. Meaning 2 divides 2k squared plus 1. Obviously, 2 times 2k squared plus 1. I'm sorry, I'm a bit ill. Caught a cold. And yeah, 2 divides it, but obviously 4 does not divide it. Okay, because we don't have a factor of 4. It just is what it is. I mean, this is completely clear that it doesn't divide it. And if we have n odd, we are going to have that n is equal to 2 times k plus 1. Meaning this is going to give us 4k squared plus 4k. Plus 1 plus 2. So plus 3. Plus 3. Exactly. And this is the same as 4 times k squared plus k plus 3. But obviously, we can clearly see that 4 does not divide 4 times k squared plus k plus 3. Obviously, I mean, this is totally clear. And this completes my proof and TED Talk. I thank you very much for listening to my shit. Yeah, this is obviously a valid proof. I mean, you don't need to do anything else here. Given x is element of the real numbers, the value of blah 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 is greater than or equal to the value of x minus 9. State giving a reason if the above statement is always true, sometimes true or never true. Okay, we are going to suppose 3x minus 28 is greater than x minus 9. So we only have a few cases to consider, I suppose. So on the one hand, we want 3x minus 28 to be greater than 0. Then we can get rid of the absolute value, obviously. That means that's equivalent to saying that x is greater than 28 divided by 3. Then we have 3x minus 28 is greater than x minus 9. If this right here is the case, okay, do we need to, yeah. And then after that, that's equivalent to saying we got 2x is greater, 2x is greater than 28, 9, 19. That means x is greater than 19 over 2, which is 9.5. And this right here is 9 dot, and then we got a third left, 9.3 period. This right here can only hold. So if it's greater than 28.3, then it's obviously also, yeah, then all the cases for x greater than 19 over 2 or 9.5 are also included. So this one works out, because our only restriction was at the start that x is greater than 9.3 period, repeating. But if we were to solve this for this case, then x must be strictly greater than 9.5, which is included in our original case that we got here. So this works out. So let 3x minus 28 be less than 0, meaning overall then x is less than 9.3 period, 9.3 repeating. Meaning, since it's the absolute value, we are going to put a negative sign to the front, meaning we got 28 minus 3x is less than okay, oh wait, we greater than or equal. I mean, this is obviously included in our case 2. This obviously works out. So this one still works out, even with the little change in order relation. So this is greater or equal to x minus 9, or in other words, 19 is greater or equal to 4x, or in other words, x is less or equal to 19 divided by 4, which is equal to 4 so we got 3/4 left, 4.75, less or equal to that. This one does work out too, right? I mean, this one still works. And this is only true for these restrictions. I mean, if we suppose that these two are the case, then they are also going to be true for these restrictions, that on the one hand x is greater or equal to 9.5, or if x is less or equal to 4.75. Yeah. Meaning it's sometimes true. It's sometimes true, but not always true, obviously. Because there are values for which this doesn't work out. For example, for 5. Let me see. So 3 times 5 is 15. X being equal to 5 is the absolute value of 15 minus 28. Is greater or equal to -4. Which obviously doesn't work, because this right here is always greater than 0. Oh yeah. No, it does work out. Huh. That's great. 4.75. Okay, very, very interesting. 15 minus 28. Oh no, I'm being stupid. No, still greater or equal -4. Yeah, this still does work out, because this right here is 13 greater or equal to -4. I'm wondering, I mean this, but obviously this must be true, right? I mean, less than 9.3 period. I think it only works out for some values. Okay, let's continue. Many empty pages. Okay, next up. A competitor is running a 20-kilometer race. She runs each of the first 4 kilometers at a steady pace of 6 minutes per kilometer. After the first 4 kilometers, she begins to slow down. In order to estimate her finishing time, the time that she will take to complete each subsequent kilometer is modeled to be 5% greater than the time she took to complete the previous kilometer. Using the model, show that her time to run the first 6 kilometers is estimated to be 36 minutes and 55 seconds. Okay. (6 minutes). In order to estimate her finishing time, the time that she will take to complete each subsequent kilometer is modeled to be 5% greater than the time she took. So the time is equal to, so we got 4 kilometers. Six minutes plus, those are the first 4 kilometers. 4. Oh, each of the first 4. So this makes 24 minutes plus, then we got 6 times 1.05. No, why 6? What? Yeah, 6 minutes per kilometer, but after that she's going to take it 5% longer. Okay, this is like for the 5th kilometer, and then plus she takes 5% longer to get the next one done. Meaning this right here is 6 times 1.05 squared. Meaning this is going to give us 24 plus 6 times 1.05 times 1 plus 1.05. So this right here is 6 6.3 times 2.05, which is going to give us 12.6 plus, then we got 0.3 plus 0.015, which is going to be 36.696 times 2 36.915 minutes. Yeah, and this is, if you use cross multiplication, you can probably get that this is 36 minutes and 55 seconds. So what you're going to say is that 1 is equal to 60 seconds, and now we're going to ask ourselves how many seconds, so how many seconds are 0.915, meaning overall we are going to get 60 seconds times 0.9 approximately. Is approximately, so 6 times 9 is going to give us 54. So 55 approximately, because we still have the 0.015 still going. So this one right here works out. Show that her estimated time in minutes to run the half kilometer for 5, R being bounded between 5 and 20 is 6 times 1.05 to the r minus 4th. How do you want to show this? I mean, what you're going to get is for the time is, it's going to be 6 times 4. Oh yeah, okay. So we don't consider the first few. So what you're going to do is you're going to have 6 minutes, and then we are going to have 1.05 and then plus 6 times 1.05, but this time squared. This is the part that we had up here. Squared plus 6 times 1.05 to the 3rd power, and so on. And yeah, this is the total time to run all of these, meaning they are just going to stack up over time. So this right here is for the 5th kilometer. This is the 5th kilometer. And this is to the first power, meaning it's 6 times, so this right here corresponds to 6 times 0.15 to the R is your lap, so the 5th lap, but you need to subtract 4 because only after the 4th lap is over, you are going to start off with the 5% reduction in speed. Yeah. Estimate the total time in minutes and seconds that you will take to complete the race. Okay, to complete the race. So the total time is those 24 minutes plus, and then we got 6 times 1.05, and then we got up to, oh yeah, that's a geometric progression, right? Oh, geometric progression, I think we got 1 minus x to the n plus 1 divided by 1 minus x is equal to x to the n plus x to the n minus 1 plus blah 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 plus x squared plus x plus 1. Meaning to the first power plus 6 times 1.05 squared plus blah 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 up until 6 times 1.05 to the 16th power. So this is 24 plus 6 times, and then we are going to get 1 minus 1.05 divided by 1 minus 1.05, but this part up here to the 17th power. To the 17th power. In other words, this is 24 plus 6 times, and then we are going to get 1 over 0.5. No, 0.05. And after that, over here it's 1.05 to the 17th power minus 1. And now you can make use of your calculator to get yourself an answer, which I'm not going to do right now. Yeah, to the 17th power, this is something you can actually evaluate in your head, because this right here is just, so this part right here is, what happened? No. My whiteboard crashed. For some reason, my Microsoft whiteboard crashed. Never mind. So this part right here, okay, what I wanted to do is you can calculate it in your head. And maybe some of the people can now see that I only take so long to answer these questions because I'm talking to the camera all the time. Last time around I got so many comments from people, I can do it so much faster than you, why are you so slow, blah blah blah. Try to record something, talk to an audience while solving questions. You are going to suck dick. Trust me, you are not going to make it in time. It's seriously not easy. So next time you comment something like this, think before commenting. So what I wanted to say here is that this is 1 plus, oh no, it's not that easy actually, because we got to the 17th power. But this is 105 divided by 100 minus 1. But all of this to the 17th power. You can probably evaluate some of this in your head, but you have a calculator, so no need to do this. And then you can estimate the time using your calc. Next up. So many empty pages. Ooh, that looks spicy. What is that? What is this, boy? Show that the x-coordinate of, oh, so we have an equation up there. Let's write it out just for the memes. Is equal to 10 times e to the negative x over 4. I'm going to rewrite it like this. I hate decimals. Times sin x. X is greater or equal to 0. Show that the x-coordinates of the turning points of the curve with equation y is equal to f of x satisfy the equation tangent and x equals to 4. Turning points. Turning points. Turning points. What is the criteria for a turning point? So let me see for a second. I think they are the second derivative must be equal to 0. And the third derivative must not be equal to 0. So let's go. First derivative is equal to, oh goodness, 10 times. So we got negative a quarter times e to the negative x over 4 times sin of x plus, oh, holy shit. Okay. Plus. Then we got the cosine x, so 10 times e to the negative x over 4 times the cosine x, which is equal to 10 times e to the negative x over 4 times cosine of x negative a quarter sine of x. Okay, f double prime of x is equal to 10 times negative a quarter e to the negative x over 4 times cosine x minus a quarter sine x. And then we're going to get, fucking hell, plus 10 times e to the negative x over 4. And then we are going to get, so cosine is negative sine of x. Then we got negative a quarter cosine x. Yeah, resulting in 10 times e to the negative x over 4 times, what the hell? Okay, so we got negative a quarter cosine of x. Then we got plus 1/16 sine of x. Then we got negative a quarter cosine x. And then negative sine of x. So this right here is never equal to 0. Meaning to have this being equal to 0, for it to be a turning point, we need this part to be equal to 0. Okay. Then we got negative a half cosine of x. Minus 15/16 sine of x is equal to 0. Show that the x-coordinate of the turning point of the curve satisfy the equation tangent of x is equal to 4. Let me see for a second. We just need to show that it needs to satisfy this. So sine of x is equal to 4 times the cosine of x, right? This is what we need to show. This right here is our condition for it to be a turning point. If we were to plug this into here, once again, okay, we are going to get so sine of x, we got a condition for that. Negative 1/4 cosine of x. Then next up, plugging cosine of x into our sine of x, so 4 times cosine of x into sine of x, is going to give us negative 1/4 cosine of x, negative 1/4 cosine of x, and then minus 4 cosine of x. Okay, that is rather curious. And I'm wondering, let me check my derivatives real quick. Okay, so we track the -1/4 down and leave this how it is. And then we differentiate the sign, giving us the cosine, exactly. Giving us cosine -1/4 sine of x. Next up, -1/4 downwards, negative plus 1/16 sine of x. The next part, plus we leave this how it is. Then we get cosine differentiate as negative sine of x. And then we get -1/4 cosine of x. Okay, but this seems to fit. Yeah, that is rather curious. I'm not certain what to do with this information. Because by this statement up here, this should already result in 0. So I'm not certain where my mistake is here. Or is it that this one right here must be equal to 0? If this one right here is equal to 0, then we have, if we plug this condition in. So let's suppose this right here is the point where we need to stop. So in the normal case, each local minimum and maximum is also a turning point. But there obviously can be other turning points in the function too. But I suppose this is what they want to do here. So we get this part right here must be equal to 0. So cosine of x -1/4 sine of x must be equal to 0, meaning cosine of x is equal to 1/4 sine of x, meaning overall that if we multiply by 4, this right here cancels out, then we get 4 is equal to sine divided by the cosine is equal to the tangent of x. And then it does work out. I think this is what they mean by this, and this right here is my proof. I thank you very much. Thank you for listening to my TED Talk. Next up, sketch the graph of h against t. Okay, so this right here is our function in a normal case. Okay, this right here is like a damped oscillator. Wow, thank you very much, whiteboard, for being fucking retarded. Something like this. Okay, this right here is our function normal case, snugging around our axis here. And this function, we know it, has, so f of x is equal to 10 times e to the negative x over 4 times the sine of x. Now what we need to do is we need to sketch h of t against all of this being the absolute value of this motherfucker. So 10 times e to the negative x, t over 4, in our case, t over 4 times the sine of t. Now this is actually really easy because this part right here is always greater than 0. This is the same as 10 times some exponential damping times the absolute value of sine of t. And the absolute value of sine of t, okay, if we just take a look at that in the regular sense, it's just going to look like the absolute value. It's just going to look like this, okay? Making bumps. Meaning our new function that we need to take a look at is basically this one right here with a bump here and then this one and next up this bump and so on, blah blah blah. All in the positives. This is our positive motherfucker used to model the height in meters of a ball above the ground, which does make sense that it's always positive. Using this model, find the maximum height of the ball above the ground between the first and the second bounce. Yeah, So what we need to do is we need to find the maxima, basically. And for this, the best way probably is to use our original function that we got right here. And then we are going to use our derivative here to get ourselves the maxima, okay, because all of our local maximums and minimums turn into just maxima. And that's going to be our height once we plug the t value into our h of t. Explain why this model should not be used to predict the time of each bounce. Okay. Oh, and we need to show the long-term behavior of this curve on B. Well, it goes to 0, obviously. So h of t goes to 0 for t to infinity because it's an exponential decay, it's an exponential damping, you could say. So meaning we're not going to take a look at this one right here. We are rather going to take a look at our f of x that we got here. F prime of x is equal to 10 times e to the negative x over 4 times, and then we had cosine of x minus a quarter sine of x. Okay, and we are not going to check the sufficient criteria because all of these are going to be maxima anyway in terms of our height that we got here. Meaning it's going to be given by the tangent of x being equal to 4. Meaning this right here must be equal to 0. Okay, it's equal to 0, meaning tangent of x must be equal to 4. This is always the case when x is equal to the inverse tangent of 4. And then we need to take a look at the first few iterations when this happens. So inverse tangent like this, and then we have like this. So at x being equal to 4, okay, this is going to be the case here, and then the case here, and so on, since we are only going to take a look at positive t or x values. The first two bounces, okay, then inverse tangent of 4. Let me check with Wolfram alpha. So all I wanted to see is what the value of this one right here is, but this really doesn't matter. So I mean, you can use your calculator for this. This is something. But more importantly, in the normal case, we are going to have a periodicity here. So pi times n plus the inverse tangent of 4. This is going to be the x value for your local minimum and maximum. So meaning what we are going to plug into our h of t is h of, for n being equal to 0, just the inverse tangent of 4, giving you 10 times e to the negative inverse tangent of 4 divided by 4. Okay, that is very curious. Times the sine of the inverse tangent of 4. And for the other one, for the next maximum, you are going to have the inverse tangent of 4 and then plus pi, because this is just the next iteration basically in our inverse tangent. So giving you 10 times e to the negative pi plus the inverse tangent of 4 divided by 4 times the absolute value of sine plus pi. is going to give you negative the sign, but this right here is going to give it the same value overall because of the absolute value. So inverse tangent of 4. So meaning to get your iterated solutions, all you need to do is add the pi n here at all times, okay, and this part right here is always going to stay the same. And then you are going to be good to go, I suppose. And this is going to be the maximum height. Yes, and this does make sense because e to the negative par plus something is smaller overall than e to the just negative inverse tangent of 4 over 4. Meaning this right here is going to be a smaller bump. And yeah, I think then we should be good to go. Punch it into your calculator and then you should be done. Okay, okay, we are nearing the end, I suppose. Okay, next up. The curve C with equation where P and Q are constants passes through point blah 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 and has two vertical asymptotes with equations x being equal to 2 and x being equal to negative 3. Explain why you can't deduce Q being equal to 4. Oh, so we can't find out Q is equal to 4 and we need to explain why. By the way, is this going to be the last one? I'm just a bit curious here. No, one more question after that. No. Explain why you can deduce. Oh no, why you can deduce. Okay. So why can you? I mean, if we know a point, then we have one equation already. So point implies one equation given. And we got two variables basically. And has two vertical asymptotes with x2 being equal to 2 and x being equal to negative 3. Has two vertical asymptotes. Why can you deduce that Q is equal to 4? Oh, due to the vertical asymptote. Let's just suppose that this function, for example, looks like this. I really don't care what it looks like exactly, but this doesn't matter. If it's a vertical asymptote, then that means that our function is obviously going to go to infinity, positive or negative infinity at these points. Okay? And for x being equal to negative 3, this is a vertical asymptote. So x being equal to negative 3, that's a vertical asymptote because then p minus 3x yeah, it crashed again. I'm so sorry. So p minus 3x divided by 2x minus q times x plus 3. So yeah, as a vertical asymptote x being equal to negative 3, our function explodes to infinity obviously. Our function goes to positive infinity there, or negative infinity. I don't give a shit what it goes to, but something infinity. If we have x being equal to 2 being another vertical asymptote, then we got 4 minus q must go to 0, meaning overall q is equal to 4. Yeah, this is how we can deduce that. So show that p is equal to 15. Okay. We need to show p is equal to 15. Okay, shall we do it? Yes, let's do it. Okay, so we got y is equal to p minus 3x divided by 2x minus q times x plus 3. But we know what q is. Q is just 4. And we know that all of this passes through the point 3 1/2. Meaning we know that no. 1/2 is equal to p minus 9 divided by, so we got 6 minus 4 is 2, and we got 3 plus 3 is 6, so 12. Meaning overall 6 is equal to p minus 9, or in other words p is equal to 15. This is what we needed to show. I thank you very much. So figure 4 shows a sketch of part of the curve C. The region R shown shaded. I really hate how they use it here. Shown shaded in figure 4 is bounded by the curve C, the x-axis and the line with equation x is equal to 3. Show that the exact value of the area of R is a times ln 2 plus b ln 3, where a and b are rational constants to be found. Okay, this is part of the curve, right? So let me sketch this really quick. So we got this guy right here. This is 3. This is the region that we need to find. For our function, I always seem to forget it. Y is equal to 15 minus 3x divided by 2x minus 4 times x plus 3. Okay, meaning we need to find the 0 of this function. So 0 is equal to, this right here can't go to 0 in, no. So for y to go to 0 we need 15 minus 3x to be equal to 0, meaning overall x is equal to 5. This is our 0. So we need to integrate from 3 to 5 our function 15 minus 3x divided by 2x minus 4 times x plus 3 dx. This is what we need to do, and this basically screams for partial fraction decomposition, I suppose. Partial fraction decomposition. That is so fucking terrible. Let me see for a second. So we got no. 15 minus 3x divided by 2x minus 4 times x plus 3 must be equal to a divided by, or we are just going to go with a, no, a divided by, it really doesn't matter, 2x minus 4 plus b divided by x plus 3. Or in other words, we are going to get 15 minus 3x is equal to ax plus 3a plus 2bx minus 4b. Or in other words, this is going to give us a plus 2b times x plus 3a minus 4b. Partial fractions, I hate it. It's such a disgusting task. Meaning 3a minus 4b must be equal to 15, and we got a plus 2b must be equal to negative 3. Meaning overall that a is equal to negative 2b minus 3. Meaning we got negative 6b minus 9 minus 4b is equal to 15. Meaning we got, let me see for a second. So this is 24. So we got negative 10b is equal to 24. In other words, b is equal to negative 5/12. Or negative and negative is positive. 5, 6 minus 3 is equal to 5 minus 18, 6, which is negative 13, 6. Okay, let's go, I suppose. 3, 5. And then we are going to get, so A is negative 13 divided by 6, 1 divided by 2x minus 4 dx. And all of this, we are going to get minus 5 twelfths from 3 to 5. And, okay. Then we are definitely going to get 1 over x plus 3. Okay. All of this dx, obviously, meaning this is going to give us negative 13 over 6. Then we are going to get, we can factor out a 1/2 here, so we got a 12 here instead of a 6. I think I'm going to go overkill here right now. I don't think that you need to do all of this, but I don't give a shit at this point. So this right here is just going to be 1 over x minus 2, meaning this is going to give us the natural log of x minus 2 from 3 to 5, minus 5 twelfths, the natural log of x plus 3 from 3 to 5. Meaning this is negative 13 over 12. Then we got log of 3. Then we got log of 1, which is 0. This one right here is going to vanish. This is 6 and this is 8. Negative 5 twelfths. Log of, we need to write it as log of 2 plus log of 3 in some kind of way. So we got log of 8. 8 is 2 to the 3rd power, so we can bring the 3 to the front, meaning this right here is going to give us 15. 15 log of 2, and then plus 3 plus 3 is 6, so plus 5 divided by 12 log of 6. But log of 6 is 2 times 3, so overall we are going to get negative 13 divided by 12. So this right here is 5 twelfths log of 2 plus 5 twelfths log of 3. That's a very fun exercise. I really like this one. No, it's fucking disgusting, but it's a lot of fun. Never mind that. So negative 13 divided by 12. Next thing we are going to get is log of 3 here and there, so plus 5 divided by 12 log of 3. And it actually works out. I think I did the maths correctly. And then we get plus log of 2. And then we got 5 over 12 minus 15 over 12. So what we got is this right here is negative 8 divided by 12. So negative, we got a factor of 4, 2 divided by 3, negative 2/3 log of 3. And then minus, this is going to give us negative 10, so 5 divided by 6, so 5 divided by 6 log of 2. I hope this is correct. That was very cool. Thank you very much. Thank you very much. And let's continue with the last exercise. And once that is done, I'm going to go to the cinema with my wife, and then we are going to watch Spider-Man No Way Home. And I'm so freaking excited about this movie. I tell you guys. The curve C in the standard Cartesian plane is defined by the equation x is equal to 4 sine of 2y. The curve C passes through the origin. Find the value of dy dx at the origin. So we need to evaluate dy dx at 0. Okay, meaning we got x over 4 is equal to the sine of 2y. Or in other words, we got y is equal to 1/2 times the inverse sine of x over 4. Okay, What I'm going to do is I'm going to go the regular route here because we already have this implicit function given. So we can say that dx over 4 is equal to cosine, this doesn't matter. So 1/4 is equal to cosine, and we have 2 times the cosine of 2y times dy dx. This is just the inner derivative, meaning dy dx is equal to 1/8, so 1/8 cosine of 2y, and cosine of 2y, so 1 divided by 8. Yes, square root of 1 minus the sine of 2y squared. And then if we plug our definition for y into there, we are going to get that dy dx is 1/8 times the square root of 1 minus, and now we get the sine of the inverse sine of x over 4, because the 1/2 and the 2 is going to cancel out, but all of the squared is just going to give us 1 over the square root, so 8 times the square root of 1 minus x squared over 16. So if we evaluate this at 0, we are going to get that we have 1/8 times the square root of 1, which is 1/8. Okay, use the small angle approximation for sine of 2y to find an equation linking x and y for points close to the origin. Okay, small angle approximation tells us that sine of 2y is basically equal, so approximately equal. So equals to is approximately equals to, okay, but just approximately to 2y. Meaning overall we are going to get x is approximately 4 times 2y, or in other words y is equal to x over 8 approximately. X over 8 approximately. Yeah, this is actually it. Explain the relationship between the answer to A and B1. Yes. Explain the relationship. For small values of x, for small x, we have that dy dx is approximately just y, probably. I mean, for very small values of x, this part is actually going to vanish, and it's going to be very close to x over 8. They are approximately equal, both of these. Show that for all points xy lying on C, dy dx is equal to 1 over, and we are done with that because this is 1 over 8 times, and then if we factor that out, we got 16 to the outs. Factoring out the 16, or 1/16, square root of, so we got a 16 here, right? Minus, no, 1/6, no, I'm factoring out the 1/16, exactly, x squared. Yeah, and this right here is going to be 2. I don't know what happened here, but this is 2. This right here is x squared, and this is exactly the relationship that they were asking for. And we are officially done. I was able to do all of these except for one. this was the one question where I just didn't find an answer to, but this didn't matter. But I am pretty certain that I was able to answer most of these correctly once again, but the marking schemes are rather difficult to understand for me, to be honest. So I'm not very certain if I would have been able to pass, but you can probably see the oh or the no once again here during the video to kind of get the approximate answers without any kind of marking scheme involved. But please make sure to leave your feedback once again down there in the comments, and if you want to see me do the further maths exam, then I would love to. Okay, please tell me, and I'm going to do more of these exams. They are a lot of fun for me and I really love to do these. And other than that, don't forget to check out stemage.eu. Don't forget to check out the collaboration with Jonathan Katz-Moses, and I hope I did fairly well on this one once again. And up to the next video, I wish you guys a flammable day, a happy new fucking year, and please stay safe also in 2022. Ciao!